this is what we did. Not too much, but we did a little bit of creating equations. So go back 200 years when books were not available, internet, etc. And the teacher had to assign equations for check for your understanding at home. Well, pretty sure there weren't too many books around either. So maybe, I'm thinking maybe it was 200 years ago and I was there. I probably had to create the equations and assign it to you guys the next day. So let's see what that looks like. So if you're the teacher and the next day you're doing equations and you want a little practice, let's start with something. Oh, hang on a second. Right. So let's start with the answer. So we're going to go backwards. So y equals 5, and my pen is not working. Okay, y equals 5. So we can, I don't know, let's start. So we have choices. We can divide both sides by a number. We can multiply both sides by a number. We can add and subtract. So I'm going to start with multiplication. So I'm going to multiply both sides by 3. Well, if I multiply both sides by 3, 3 times y equals 3y. And on the other side, 3 times 5 is 15. So there you go. I just created, and this is a one-step equation, right? Very simple equation that I can give to my student the next day. 3y equals 15, think about it. The one-step equation, he would have to divide both sides by 3, right? 3 divided by 3 is 1, 1 times y is y, and then 15 times 3 is 5. So that would be the work that he would be doing, and then he could check, 3y equals 15, replace the y with 5, 3 times 5 equals 15, and 15 equals 15. So just that little equation, look how much practice he would have to do, right? But obviously, we don't want to keep it at one-step equations. We want to hopefully move. So from one-step equation, the following day, I want to give him two-step equations. Well, two-step equations are equations where you need to do two inverse operations or two operations to solve your equation. So let's add 12 to both sides. So I'm gonna make that equation a little bit more complex. So 3y plus 12, well, I can't add those two because they're not like terms, so this is just 3y plus 12. And on the other side, 12 plus 15 is 27. Ta-da! We just created a two-step equation. Right? So again, I'm not going to solve it, but 3y, well, maybe I should. 3y plus 12 equals 27. What would be the first step here? We would subtract 12 on both sides, and we get 3y equals 15. And notice that this will become this, will eventually become that. And again, I don't want to solve it because I just did. So again, I just created two equations, and I know the answer to both because they're both equal to y equals 5. So I already have my answer sheet at the same time. Now, I want to make this a little bit more complicated. So let's add parentheses. Well, there's two ways. There's, I guess, two different ways you can add parentheses here. And I'm going to take that here. One way could be maybe I can factor this out, right? Factor the 3y plus 12, and I can take the greatest common factor, which is between 3 and 12, which is 3. So I can change that, right? And I can say, well, maybe I want to rewrite the question as 3y plus 4 equals 27. So again, the next day you can give the student 3 parentheses y plus 4 equals 27. So that just added an extra step for him to do, right? And so instead of now straight to subtracting 12 from each side, he's obviously forced to do the distributive property, which gives you 3y plus 12 equals 27. And then minus 12 on both sides, etc., etc. So you just added another level of difficulty for him to do. So that's one way of adding parentheses to the question. Now, I'm going to make, let me see if I can pull this guy. Can I? No, I can't. Maybe 3. So what I'll do is I'll erase. And then to add parentheses, there's two ways. So one way was that. You factor it out if your numbers are nice. So if that was 3y plus 10 equals 27, let's say, can you factor something else? Can you take the 3 out? Can you take a common factor out? You can't, right? So sometimes that method is not going to work. So in this case, it worked. Y plus 4 equals 27, right? So that's one way. So another way we can do this right, is that we can multiply again both sides by, I don't know, let's pick 4. Multiply by 4. And look what happens when I multiply both sides by 4. On the left side, 4 times, and I'm going to multiply everything here, 3y plus 12. And on the right side, 27 times 4. It's 108, I think. So that's another way of adding that parentheses to your problem. Okay, so again, the kid next day would have to do distributive property, etc., etc., etc. Okay. Again, so you have these two. I mean, from here you could have gone to the left or to the right, and that's fine. And the other thing I wanted to do, we're going to ask you to do, is to add variables to both sides. So we're going to add variables to both sides. So how do we do that? Well, let's say I want to add plus 10y to both sides. So on the left side, and I'm going to go 3y plus 4 plus 10y. And on the other side, just to make it a little bit more, instead of just writing 10y, remember, I have to add 10y's to both sides. So here I'm going to add 13y plus 27 minus 3y. Well, isn't 13y minus 3y the same thing as 10y? So instead of writing 10y, I wrote 10y. I wrote an equivalent expression as 13y minus 3y. It's the same thing. Because remember, if you combine these two, combine like terms, 13y minus 3y eventually gives you 10y. So I just express 10y in a different way. So, and by doing that, it adds another level, or I don't know, I'm not going to say difficulty, but it just adds another step that he has to do, another skill that he needs to be aware of. So now, if you're solving this problem, right? So now, what do you call it? Let's solve it. So I'm going to stop. So there is as far as I want you to go today. All right, so you created 4 different equations. One equation here that has distributive property, combining like terms, variables on both sides. Or 2, just a less complex one, just distributive property. 3, a 2-step equation, 3y plus 12 equals 27. And then a very simple one, a 4th equation, 3y equals 15. So, and guess what? They all equal 5. So, starting with the answer, as we created and made them more complex, a little bit more complex, step by step, you created 4 different problems. And again, when you solve it, you'll notice that this, again, will become this will become that, and so forth until you isolate the variable and you end up with 5. Okay, so that's pretty much what we did today. I'm going to do a couple more. Let's pick something that's negative. There we go. So this one, c equals -3. So let you know. Let's divide both sides. Let's divide both sides by 4. I don't know. I'm just picking. So this would be c over 4 equals -3 over 4. Okay. So that's my 1-step equation, a very easy 1-step equation. Let's add or subtract next. Let's subtract because we haven't done that. Let's subtract 10 from each side. So c over 4 minus 10 is just c over 4 minus 10. On the other side, -3 over 4 minus 10. So if you think about -3 over 4 minus 10, okay, that's 0.75. Well, you can leave it as a fraction. It really depends what you want to take it here. So I'm going to leave it as a fraction, and I'm going to call that -10 3/4. Okay. So that we have now a 2-step. And this one has fractions. We can add distributive property if you like. And I'm going to put a parenthesis here to show that next step. I'm going to add distributive property, make the equation so that it has distributive property. And I'm going to multiply it by, I don't know, 8, only because 8 and 4 are going to cancel nicely. So 8 times c over 4 minus 10. And on the other side, I'm going to multiply 8 times -10 3/4. And you have a calculator, okay? So instead of, so I'm going to multiply that 10.75 times 8, 10, 3/4 times 8 equals 86. So look at that. That's a nice number. So negative 86. So I multiply both sides by 8, and I got negative 86. And again, the next step here, again, if we're going to add variables, add or subtract variables to both sides, just to add a little more complexity. And let's subtract, I don't know, 2c. So I can say minus 2c plus 8, c over 4 minus 10 equals. And on the other side, like I said, I can express negative 2c in different ways. So I can say negative 86 plus 5c minus 7c. Isn't 5c minus 7c the same thing as negative 2c? So I'm subtracting 2c from each side. All right, so to the left side, I subtracted 2c. And then to the right side, I'm also subtracting 2c. And again, let's just take it this far. And hopefully you guys are back tomorrow. So again, we have our most complex equation has distributive property, has combining like terms. And then that's our most complex. The second most is, okay, first most complex, second most complex is this one. This just has distributive property. It doesn't have combining like terms. This one is just two-step equation. And the first one that we created is just a one-step equation. Okay. We'll do one more. Okay, we'll do one more. Let's, I don't know. Let's add 5 to both sides. So let's see. What happens if I add this? Let's start with addition. So k plus 5. And then, what do you call? 10 plus 5 is 15. Now let's say I wanted to multiply both sides by something. Now if I do that, automatically, I have to put that in parentheses because it's 2 times, so it's 2 times everybody, right? 2k plus 5 equals 30. Now if you didn't want to do that and put it in parentheses, your other choice was to just multiply. So 2 times k is 2k, and then 2 times 5 is 10. So either you write it like this, or you write it like this. Notice that it's the same, sorry, 2 times 15, sorry, this should have been 30. So it really depends on how you want it. So if you could have done this. So here is my one-step equation. Here's my two-step. And maybe then, if you didn't want to, if you didn't want to, I don't know, waste that step, I guess, you could have, the next step, which would be adding parentheses, you can factor this out and write it as 2k plus 5 equals 30. So it's up to you how you multiplied by 2 here. Okay, so you either multiplied, right, and did the distributive property right away, or you kept it like this. It's really up to you. Okay. And again, add variables to both sides, plus or minus. Let's pick, we subtracted, let's add, I don't know, 4k to both sides. Let's 4k to both sides. So here I have 2k plus 5 plus 4k. If you want to complicate this, or you know what, let's make it something like this. How about 12k plus 2k plus 5 minus 8k, right? So isn't 12k minus 8k 4k? So I'm expressing 4k as 12k minus 8k. On the other side, I also have to add 4k, so we can go 30 minus 17k plus 21k. There is a negative 17k plus 21k, same thing as 4k. So that's your more complex fraction that you can create. And guess what? All these 4 fractions, all these 4 equations, they all have k equals 10. Okay, so if you can print what do you call the handout that I'll post along with this, you can print it out. Otherwise, just do it in your notebook. Okay. All right, that should be it.